In this video, you will begin to learn about properties of real numbers. A real number is defined as any number that can be plotted on the number line. And all the numbers you've studied thus far in any of your math classes are real numbers. So any point that could be anywhere on this line, so we could have -3, something over here, all these numbers are examples of real numbers. And every real number can be graphed as a point on the number line as shown below. So -3.5 would be between -3 and -4. -7.6 would be between -2 and -1, and etc. for the other numbers. Now, in order to graph each number as it on the number line, you have to first rewrite it as a decimal and then plot the number. So if we wanted to graph -5/2, if you plug in -5/2 in your calculator, it would give you the decimal -2.5. Now if we want to graph that below, -2.5 will be between -2 and -3. So we can write our number in and draw it in above. For the next example is square root of 2. Now if you plug the square root of 2 in your calculator, it would give you 1.41 and rounded to 1.41. Now if we want to graph that, that'll be between 1 and 2. So it'll be somewhere in this area. We're going to label that as the square root of 2. For the last example, 2.6 repeating is really 2.6666, and the 6 would keep repeating. If we want to graph that, that'd be between 2 and 3 and be about here. So your answer would be 2.6 repeating. For all these examples, as long as your numbers are within the right range of two numbers, you'll get full credit for these questions. Now, in order to compare real numbers, we use inequality symbols. So the one that has the arrow with the bigger side open to the right is what we call our greater than symbol, and when it opens in the opposite direction, it's what we call our less than symbol. And the inequality should always open towards the larger number. So if you want to think about it as a hint, think about like the crocodile mouth is going to open to eat the bigger number. So since 8 is the bigger number in this case, it's opening towards the 8, like the crocodile is going to eat the 8. Now in order to compare numbers, we need to first change them into decimal. Now this is really the square root of 17. And if you plug the square root of 17 into your calculator, you would get 4.12. And this number stays as 3.8. We always want to remember that the inequality will open towards the bigger number. So in this case, since 4.12 is bigger, the inequality symbol would open to that side. So if we want to rewrite our answer, it would be that square root of 17 is greater than 3.8. For the next example, the square root of 26 is really 5.099. The other number stays as 6.25. Since 6.25 is the bigger number, it's going to open towards that direction. So we can rewrite it as the square root of 26 is less than 6.25. For the next example, it says, let A, B, and C be real numbers such that A is less than B and B is less than C. How do A and C compare? Now, if we draw a number line, we know that A is less than B. Since A is less than B, if A is over here, then B is going to have to be on the right of it. Now for the next part, it tells us that B is less than C. If B is here, C is going to have to be on this side of B. Now if we were to compare the two numbers, how do A and C compare? A is less than C because it's further to the left. In the next section, we're going to talk about rational and irrational numbers. A rational number is the set of all numbers that can be written as a fraction or a quotient of integers a divided by b such that b does not equal 0. Now, the set of rational numbers also includes any terminating and repeating decimals. Terminating is something like 6.5, 2.25, something that ends, versus a repeating decimal would be something like 6.888 repeating, which we can really write as 6.8 with the little bar above it. Now, if we look at the examples, 7 over 6 is an example because it is a fraction. 4 is an example because we can rewrite that as 4 over 1, so it's also a fraction. Both 0.75 is a rational number because it's a terminating decimal. And same thing for 2.73. That's also a terminating decimal because it ends. Versus 0.2 and 3.45 are both repeating decimals. Irrational numbers are decimals that do not terminate or repeat. And this includes all numbers involving pi or square roots that are not perfect squares. Now, in our example, both pi and 4 pi are rational numbers because they include pi. If we plug in the second square root of 3, that doesn't give us a whole number. It would give us 1.73205 and never ends. If I plugged in square root of 5 plus 4, it would give us 6.236068 and keep going. Since neither of these change, they're both irrational. Now, for pi minus 2, this includes pi, making it irrational. The one that is different is if we plugged in the square root of 4, that equals 2, which is really 2 over 1. Since this is a fraction, square root of 4 is not an irrational number. For the first example, we have 61 pi. This would be an example of an irrational number and the reason for that is that it includes pi. For the next example, 42 can be written as 42 over 1, making it a rational number, and that's because it can be written as a fraction. .621 and with the 1 3 repeating is what would be considered to be a rational number, and that's because it's a repeating decimal. Square root of 17, if we plug that in the calculator, would give you 4.123, And since this is 4.12310, this is what we would consider irrational. And that's because it gives us that square root that's not a perfect square. For 6.7148113, this is also irrational because it's not terminating and not repeating. For the last number, if we found the square root of 25, that would give us 5, which is 5 over 1, which makes it a rational number since it can be written as a fraction.